All right, hey hackers. So first of all, before I continue and all that, the streams had to be cut off if you didn't know because Hack the Box, you can't live stream during the CTFs. For whatever reason, that completely went through my head, so I apologize if I did cause any trouble for Hack the Box or anything like that. But I'm here now, so I'm deciding to record this, and I'm gonna set it as a premiere for you guys to watch as if it was like the live stream. I'm gonna edit some of the like white space out, so you're not just watching me stare at the screen the whole time. But this should be a better viewing experience for you, so that way you can kind of see what challenges I did and how I solved them and things like that. So while that's happening, I guess we should, get back to the work, right? So my friend David, you probably saw him on the live stream or during NobCon. He's taking care of the Blitzprop, and I'm gonna take a break from Blitzprop for a second. And instead we are going to work on Nintendo Base 64. So the prompt says, aliens are trying to cause great misery for the human race by using our own cryptographic technology to encrypt all our games. Fortunately, the aliens haven't played Crypto Hack, so I need to keep note of that. Fortunately, the aliens haven't played Crypto Hack, so they're making several new mistakes. Therefore, they have given us a chance to recover our games and find their flags. They've tried to scramble all the data on a Nintendo 64, but don't seem to understand that encoding and ASCII art aren't valid types of encryption. This challenge will wait 33 euros for a good cause. Cool. I guess we should just download this stuff. Save. Home/downloads. And then everything.zip into our current directory. Cool. We can control D, so we can unzip. So we have this output.txt file. You can check out this output.txt, and it says Nintendo 64. Alright guys, so it's 8 lines, and it says Nintendo 64 times 8 and Nintendo Base 64. So this is probably encoded, this is probably Base 64, but they just like, it's probably like 8 times. They encoded it like 8 times, right? No? I guess we're about to find out. So let's go here, and so we'll say this as Nintendo 64 decoder.py. Let's see if we can use Python for this. So import base 64. No. Of course, we can use the /user/bin/python. Alright, so then we can do data and have it be equal to our output.txt. Oh, actually, you know what? Now that I think about it, alright, so Control F, find just all the spaces and just replace all of them. There you go. And find all of the backslash and new lines using, oh, okay. So we can use the regular expressions right here, replace all. So let's use this, Control V. There you go. So we have that line. So this is our base 64 string from output.txt. All right, and now we need to decode it, right? So we can do decoded data, data is equal to base 64, and then what's it like, dot decode, no, it's B64 decode data, right? And then now we can just go ahead and do the decode, we'll just call it flag. Flag will equal the string version of the decoded data. So if we clear all this, whoops. Yeah, I was trying some Python earlier, it wasn't really working. But now I think I know what I'm supposed to do. So if we do Python 3, yeah, Nintendo 64 decoder.py. Did we not print it? Oh, yeah. Cool. So print flag. So this should decode it. All right. So now we need to do a for loop. So flag equals decoded string. So now we just had to do this 8 times, right? So for I in the range of 1 to 9, because that'll be 1 to 8. We can just do flag. Well, if we decoded it once, we only need to go to 8, and then we can just do base. We can literally just copy this line right here, like this. Base 64.decode. Instead of data, we will use flag, and then we can call this. Okay, I have a better idea. So we're going to take this, and then data will equal the new version of the data. But instead of it being a string, it will equal the decoded data. So we'll have to go back to the range of 9. All right, and we can comment that out for now. So, and then have that. So for I in the range of 1 to 8, it will get the decoded data of base 64 decode data, and then it will make the new data variable equal the decoded data we just decoded, and it will do that 8 times. And then we can print data. So if we run that, yes sir. What is it? All right, there you go. All right, so submit flag. Take your time. If this does work, then Nintendo 64 tech-decoder.py. And then we get this flag. We solved it. So basically, what we did is Cyberpocalypse. Oh, what we did is I'm tired, y'all. So what we did is this was the output of the txt file, the output.txt file, right? It was just this thing. So I figured they just decoded the they decoded the base 64 that this is composed of 8 times. So I made a Python file, right? So the flag is all this decoded stuff. Then I just did for I in the range from 1 to 9, and in Python that's 1 to 8. It will decode the data, and then we'll decode the data, save it, and then re-encode that same data 8 times until we get the flag, and it'll print the flag out. So there you go. Hey hackers, Blue Cosmodium from CCS here, and welcome back to HackTheBox Cyber Apocalypse 2021. It is currently Wednesday, so we have about 2 days left of this. And my friends were saying, which one is it? Phase stream is pretty simple to do. So I'm going to go ahead and try phase stream. And I might try the other phase ones if that one's pretty good, and we can keep going from there. But otherwise, let's kind of just jump into it, So, here on the website, let's go to crypto. I believe it's in, phase stream. All right, so what's this say? Excuse me. The aliens are trying to build a secure cipher to encrypt all our games called phase stream. They've heard that the stream ciphers, They've heard that stream ciphers are pretty good. The aliens have learned of the Zor operation, which is used to encrypt a plain text with a key. They believe that Zor using a repeated 5-byte key is strong enough, or is enough to build a strong stream cipher. Such silly aliens, here's a flag that they encrypted this way earlier. Can you decrypt it? Yes, we can. I hope. A hint is, what's the flag format? Oh, I already know. I think I know what we're supposed to do. So I think they shouldn't put that hint there, because I would have not figured. So the fact that they asked the flag format means we should be using the format in order to find the key, right? Or find the flag. So they believe that we're using a 5-byte key. Okay, so a stream cipher I'm mildly familiar with. I need to get, but I do know what Zor is, so I guess I do know what it is. But I know you can use Zor with Python. So a stream cipher is a symmetric key cipher where the plain digits are combined with a pseudo-random cipher digit stream cipher. Yeah. So let's see if we can use Python for this, because whoops, I did not. Stop. Cool. So let's go ahead and copy the flag, and we can go over here, and we can do a phase stream 1. Right. So encrypted flag. Actually, we can do flag encrypted via Zor, which is a stream cipher. So here's the encrypted flag. Cool. So now we need to we know that we need to decrypt flag. So decrypt the encrypted flag with a 5-byte key. Cool. So that's what we need to do, right? The question is, how do we do this? I'd like to use Python if possible. So let's actually go ahead and try that. So we're going to open this up and we are going to do touch phase stream 1.py. Cool. So right here is phase stream 1.py. And so we'll have to do the same old /user bin Python. So I know we can get the key using Python's like pawn tools or pawn. So let's see if we have that. So if we pip3 freeze. Hello. Oh, I was hitting the shift instead of the Z. So pip3 freeze, and then we're going to grep for pawn. Yeah, there you go. So we do have pawn, and we do have pawn tools. So we're going to use pawn, and in order to do that, we will have to import it in 1 second. So tool to get phase stream 1 key. So we know the key is 5 bytes, so I'm going to put that right here, 5 bytes. And then, of course, we'll have to give ourselves some credit. So created by Cosmo. Cool. So we need to, what do we need to do? We need to import tools. So we can do from pawn import Zor, I believe. Oh, I put form. So from pawn import Zor. There you go. So we also need to put the encrypted flag in here. So encrypted flag is equal to the bytes form. So we need to do bytes dot the hex form, right? Hex form. Hex form. That's not right. Wait, so it's bytes dot hex form? I don't think that's right. It's from hex. Okay, yeah. My bad. I am tripping, because I knew that wasn't right. I am tripping. I am tired. All right, so let's put the key in here, and now we have the encrypted flag via Zor. Cool. So now we can actually use the flag format to find the key, right? So we can do on a flag format is equal to the bytes version of the flag format, which is C HackTheBox, and then that first one like that. So that should be right. So we can do bytes form of flag. There you go. So now we need to actually, use the join character to actually get the keys. How are we going to do this? So plain text key equals an empty string dot join, and we're going to join the characters. Let's index C, that's M. I'll explain what this is in a second. I'm just going to do for C in the zip version of the encrypted flag and the flag format. All right, so basically this should get the key for us, right? So gets key based on this gets the key based on flags formatting. Cool. So we're just joining each character and using the flags format to encrypt it, so it's doing for each one and each one. Okay. So last thing we need to do is output the key, right? Output key, and we can literally just print out the key. So plain text key, save that. All right, so if we run this, we can just do a Python 3 phase string.py. Is this seriously my key? Like I could have guessed that. That's seriously the, okay. So I'll just leave it in a comment for you guys to read. Key is equal to my key. Cool. So we got that. So now we can say use phase string 1.py to get key, and the key was my key. So now we can actually, do the rest of the decryption process. So if we go on, let's use decode. I don't know if you guys heard of decode or not. You probably have decode, and they have a XOR thing. Yeah, decode right here. Cool. So let's put in our flag right into here, and then use the ASCII key, and the ASCII key is my key. Now we can decrypt, and wow, there you go, that's a flag. Cool. All right, so we can put that in here. Let's submit the flag. Submit. Hey, let's go. All right, awesome. So let me finish writing these notes. So my key. So we know the final flag is this thing. So you can use this link right here. So use this to decrypt. There you go. So we got it, phase 3.1. That's how you do it, using known plain text. Awesome. So if we refresh, it should say that we have the key submitted. Crypto. Yes, sir. All right, bet. Hey hackers, Blue Cosmodium from CCS here, and I know, different orientation. I'm up here now instead of down there because I figured I have all this corner space on the top of my browser, so I figured me being up here would be a little bit better, just so you guys can see more of what I'm doing. I also made my bar go disappear, which I kind of like actually. Like it drops down if I'm not over it, so I get more screen orientation, and I can still use the Alt tab to cycle between apps. So yeah, so I guess we should start phase stream 2. So let's read the information. The aliens have learned of a new concept called security by obscurity. Fortunately for us, they think it's a great idea and not a description of a common mistake. We've intercepted some alien comms and think they are Zoring flags with a single byte key and hiding the result in 9,999 lines of random data. Can you find the flag? Hopefully. Cool. So let's download the information and we'll save that. Then we can head over to our terminal, move everything in the home/downloads directory, everything that's a zip, .zip, and then move it into our current directory. Cool. So there you go. You guys should be able to see that better. I just realized I should make my terminal bigger, but now you guys can probably see what I'm doing a little bit better. So let's touch a new file, phase stream 2.py, because I mean, if we solve the first one with Python, we'll solve the second one with Python, right? So let's control slash with this, and oh yeah, so we need to unzip the file, so it should be like crypto, I think, and then ps2. That's it. There you go. So we got the output.txt, and we're going to rename this output.txt. So we're going to move output.txt to phase stream 2 download.txt. Or I'll call it output.txt because that's what you make. So phase stream 2 output.txt. There you go. So we know which one it is, because there was the other output.txt that contained this, but I deleted that output.txt because I already have the contents in the README. So you guys don't have to worry about that. So let's actually make our README section for this. So this will be phase stream 2, right? And I guess we should open this phase stream 2 output.txt, and it is a bunch of encrypted flags from what it seems like, right? Because we have this encrypted flag from the last one. So this has to be some sort of encrypted flag, or a set, or 9,999 encrypted flags, right? So what I'm figuring is we do what we did in phase stream 1.py. Basically, we get the flag for each. We'll iterate through the list, right? We'll iterate through this output.txt. We'll get each encrypted flag, and for each encrypted flag, we will get its key and decrypt it through Python. So that's the plan. Yeah. Cool. All right. So I guess we should let the users know about what we're doing. The phase stream 2 tech output.txt contains quad 9 encrypted flags. All right, so we know that. So now let's use our phasestream2.py and get this, right? So we're going to need to, of course, do the Linux thing. So /user bin Python, then tool to get the phase stream 2 key, and these are 1 byte. And then of course created by Cosmo. All right, so we need to import our tools, right? So of course we're going to need the pawn tool, right? The for Zor. So import from PWN import. Let me actually make this bigger for you guys. Whoops. And close that. There you go. That's hopefully a little bit better. So from PWN import Zor, right? Nope. From iter tools, because we're going to need to do some cycling, and I'll show you what we're going to do with that in a little bit. Cycle. And then I think that's all we're going to need. So we're going to need to get the encrypted flags, right? And we will say that to, I guess we'll call this flag list, right? Flag list equals open the file, which is phase stream2 tac output.txt, and we're going to open this into read mode, and we're going to read lines. So we're going to read the lines of the file. All right, and now we need to actually start the decryption process, right? So decrypt. Oh my gosh. Decryption process. So we're going to do for line in the flag list. We're going to have each line be stripped, so that way there's no new lines, there's no weird spacing. It's going to format them, format the flags properly. And then we're going to get encrypted flag, and this encrypted flag, we'll have to do the same thing that we did last time, the bytes from hex, right? Instead of hex form or whatever I did last time. Cool. So we have the from hex, right? And we're just going to have it from each line. Cool. So this will basically format flag. Cool. So this will format the flag. And we will also have the, funny enough, flag format. This is basically the same thing I did last time, right? The flag format, and this will equal to b CHTB this delete that delete. All right, so that looks fine. What else do we need to do? We need to get each key. We need to get the key of the flag that we're currently using, or the current encrypted flag that we're going through. So in order to do that, well, first we need to get key based on the flags formatting. Cool. So with that, we can, in fact, I'm too lazy to rewrite that whole thing. So we're going to go to facestream1.py. We're going to copy this, and we are simply going to paste it. Awesome. So now we have, let me control /. There you go. So now we have the plaintext key, which is used to encrypt or decrypt this flag right here. So let's say we're on this one. I'll actually explain what the code is doing right now. So for line in the flag list, right? This just gets every line from this file, right? So it'll go through each line. So on the first line, it will strip the first line, so that way it's just the first line characters and everything. Then it will get the encrypted, like get the hex version basically of it. Then it will use that formatting and use this flag formatting to decrypt, or not decrypt it, but to get the key. And now we get the key. So now we're just going to, from here, decrypt the encrypted flag. And the reason I didn't do this last time is because simply I was lazy. I didn't want to code another section where it would also decrypt the flag in the same script. I could have easily done it, to be honest, but I didn't. So this time, let's decrypt it in the Python script, right? So I guess we have to, because we're not going to go to the website 9,999 times in order to decrypt this, encrypted flag. So from here, we're going to call this flag, because this is going to be the final version. So same thing that we did before. So we're going to join it. Then we're going to get the character, and we'll use X and Y this time. Actually, you know what? We'll use C and M like we did last time. So character C, and then the, what's it called? Caret. I think that's called the caret. I don't know what that's called. And then we're going to get the order. CHR, character, and ORD, order. That's why I call them. They're for Unicode. I think I'm making a video on it in a couple of, I don't know. I'm making a video on those types of commands in the future, just so you guys can be a little bit more clarified on what I'm doing right now. But with that, we can exile those two, and then we'll do it. That for C and M. Well, I don't need the quotes, do I? For CM in the zip version of the encrypted flag. And we're going to have to cycle the plain text. And there you go. That should be it. So all we have to do is output the flag, right? So output flag, and, or output flags, right? Because this is going to be multiple. So if the flag starts with the flag formatting, right? But it can be binary. So CHTB, this thingy. So if it starts with that, and, whoops, and the flag ends with curly brace, then we can print the flag. Cool. So that's it. So we can clear that, and we can Python 3 phase stream 2.py. And I did the decryption process wrong. B is not defined. Where did I put B? Oh, order M. Let's try that. There you go. All right. Cool. So we have a bunch of these. So I'm assuming out of the 9,999, these were the ones that fit the flag that we're looking for. All right, let's see if any of these. Oh my gosh, needle and haystack. There you go. Is that the flag? Submit flag. That should be the flag. This website's so slow, dude. All right, so I'm assuming that's the flag until further notice. So let us go to phase stream 2 and then, all right, so we can put the flag right here and then, so we know the file does that. So we can say use phase stream 2.py to get list of possible flags, a list of flags most likely to be correct. So I'm assuming this is the right one. All right, let me refresh it because I'm assuming it counted it. Crypto. All right, cool. There you go. Awesome. So yeah, I'll go over the code super quickly. So basically we use these two modules in order to get through the processes that we need to do. This first part up until here is the exact same thing that we did for phase stream 1, right? So this right here gets every flag in this list of encrypted flags. So it'll go through each encrypted flag in that list. It will strip it so that way it's just the actual encrypted flag. Then it will switch into hex form, and using this format that we know that the flag is in, it will use that to get the key that is used to encrypt it. From there, we can decrypt it with Python using the flag, the same way you would do on a website or anything like that. Then we just formatted it so it would only display the flags that started with this and ended with this, and then it would just show it. And then it did that for each item in this area or this list. That was it. And we got this, and there you go. So cool. Hey hackers, so that is unfortunately the end of the CTF. I worked pretty hard as much as I could, especially with the school week going on. I was still taking classes and stuff, so I'd have to do it after track practice and all these other things. But it was overall a lot of fun, great experience. The CTF notes are on my GitHub. Link is in the description as always. So make sure to check them out if you guys weren't able to follow through with what I was talking about throughout the video. I had to cut a lot of the content out of the video because I did attempt some other challenges like Blitzprop. I believe, yeah, Blitzprop and Authenticator and Passphrase. I did try them, but I never fully dedicated to finishing them. So I hope you guys enjoyed it. Hope you guys got your certificate on the HackTheBox website, the same place where you took the CTF. But regardless, that's the end. I will be posting some more videos in the future. Every Monday is the times I post. So you guys will probably see me on Monday, or that's probably today, the time this video is being uploaded. But yeah, so make sure to like, subscribe, because we just hit 100 subscribers, and let's see if we can get to 1,000. So yeah, happy hacking.